Calculate the currents in the following circuit. The circuit is given. Good. Let us know the path. KCR, Kirchhoff current rule. Sigma I at a junction equals 0. KVR, Kirchhoff's voltage rule. In a loop, sigma IR equals sigma epsilon. Solution. Good. Here in the circuit, few components are not given labeled. They are not labeled. Calculate the currents in the following circuit. The circuit is given. The path. KCR, Kirchhoff current rule, which says at a junction sigma I equals 0. KVR, Kirchhoff's voltage rule. In a loop, sigma IR equals sigma epsilon. Solution. Here in the circuit, few parts, few components are not labeled. So let us label them one by one. Here the 15 volt is given epsilon 1. Then 9 volt is given epsilon 2. Then the horizontal resistance is R1, the vertical resistance is R2. So let us label the path A, B, C, D, E and F. Good. Now applying KCR at the junction B. At the junction B, I1 is the current coming towards the junction is positive. I2 and I3 are the two currents going away from the junction. They are negative. B. So total current going towards the junction equals the total current going away from the junction. I1 equals I2 plus I3. So to simplify this problem, let us have only two variables. So let us have I3 equals I1 minus I2. Let us have this equation somewhere here near for further reference. I3 equals I1 minus I2. Now, applying KVR around the loop A, B, E, F, A. A, B, E, F, A. So, let us draw a yellow path. Good. At this yellow path, in this yellow path, let us consider the direction of traversal is in the clockwise direction. The same one has to be followed in other loops too. The clockwise direction is the direction of traversal. Now, here I1R1 is in the direction of traversal. So, I1R1 is positive. So, I1R1 is positive. I1R1 is positive. What happens to I3R2 is in the direction of traversal, so it is also positive. So positive I3 and R2. Good. So let us find what is the sign of epsilon 1. Good. Right. The direction of traversal goes from negative terminal to the positive terminal. So epsilon 1 is positive. So let us write the equation. I3 R2 plus I1 R1 equals epsilon 1. Substituting the value of R2 and R1, we get 100 I3 plus 100 I1 equals 15. Good. Let us substitute I3 as I1 minus I2 in the equation. We get 100 times I1 minus I2 plus 100 times I1 equals 15. Right. Now we have 100 I1 here, then another 100 I1 here. So totally we have 200 I1. Then minus 100 I2 equals 15. Let us have this equation for further reference. 200 I1 minus 100 I2 equals 15. So let us go for the next loop. KVR for the loop B, C, D, E, B. Let us sketch this path in yellow color. Good. Now we have to find what is the sign of I2 R3. Good. I2 R3. The direction of I2 is in the direction of traversal. So I2 R3 is positive. I2 R3 is positive. Whereas the direction of traversal, let me say this way, the direction of I3 is opposite to direction of traversal. So we have minus I3 R2. And now the direction of traversal is from positive terminal to the negative terminal in the EMF epsilon 2. So epsilon 2 is negative. Let us write the equation based on this. I2 R3 minus I3 R2 equals minus epsilon 2. Now let us substitute the value of R3 and R2. R3 is 100 ohms. So 100 I2 minus 100 I3. In the place of I3, I substituted I1 minus I2 equals minus 9. 100 I2, once again minus 100 minus or minus plus, so another 100 I2. So totally I have 200 I2 minus 100 I1 equals minus 9. Let me multiply the equation by 2. So I get 400 I2 minus 200 I1 equals minus 18. Let me keep it here for further reference. Good. Now, this is the first equation and this is the second equation. When I add these two equations, right, this 200 I1 get cancelled with this 200 I1. Good. Now here you have 400 I2 minus 100 I2. So what you get? You get 300 I2 equals 15 minus 18 equals minus 3. So let me go with I2. I2 equals minus 3 divided by 300. So you get I2 equals minus 0.01 ampere. So one of the result we get. So we know 200 I1 minus 100 I2 equals 15. In this, let me substitute I2 as minus 0.01 ampere. So I get 200 I1 equals 15 plus 100 times minus 0.01 ampere. So 200 I1 equals 15 minus 1 equals 14. So I1 equals 14 by 200. I1 equals 0.7 ampere. When we know I2 and I1, by using this first equation, we can find I3. I3 equals I1 minus I2. I1 is 0.07 minus of minus 0.01. So I get I3 equals 0.08 ampere. Right. I1 is positive. That means the direction of I1 is in the direction of traversal, which is confirmed. Then I2 is negative. That means I2 is not in the clockwise but in the anti-clockwise. What we assumed is wrong. Good. So I2 is coming negative because it's against the DOT, direction of traversal. The final sign is okay, decides the direction, the actual direction of current. Then I3 is 0.08. So I3 is downward. That is same as we have decided. Good. Thank you, children.